fastener. So it's completely universal and or it's repeatable and reversible. So the frame in itself causes no damage to the vehicle, and once you remove it, you can never tell it was there. The idea the idea is to provide sufficient support to hold a much larger engine that was too much for the stock transmission to hold. And so the frame would be required to support all the additional mass hanging on the back. The calculations were for on-road and off-road conditions, and to verify that the frame was as strong as it needs to be. I planned on loading it with a bunch of weight, measuring the deflection, and then showing that that correlated to what the frame should result with in the deflection. The requirements are listed here. For this specific application, I chose a Toyota 20R engine to put into the back of my 74 Beetle. The frame is universal enough that you can put other engine mounts on it. So you can put other engines into it. The idea was that it weighs fairly light, so less than 150 pounds, so it is a small percentage of what the total weight of the vehicle is. It needed to have a safety factor of 4 during road conditions. Off-road conditions are quite varying, so I specified a 4-foot drop, but I did not specify a specific safety factor for it because I was just shooting for safe on the road for the meantime. It had to remain close to the vehicle, so it did not impede your ground clearance. And as I said before, I had to use the stock location. That was really important to me, to not have to weld onto the vehicle or drill any new holes or any of that. So the assumptions were for a 500-pound engine. The engine mounts would be 20 inches out, so that would be a cantilever of where the engine would be supported. For the deceleration for the 4-foot drop that I was using for my off-road calculations, I assumed a 0.22 second deceleration. And I also assumed that the points on the vehicle that I located would be viable for this conversion, and that for on-road use, going over speed bumps and dips in the roadway, that 2 Gs would be sufficient for a vertical increase in load. Things that were not required, but I liked, were to use recycled materials to keep my costs down, and as I said before, to accommodate other engines. So for the design, this is the design I came up with. It's kind of hard to see here, but this is one of the locations I had for mounting. There's 2 bolts for the nose of the transmission here, and there's on the ends here are the points for the tail of the transmission to mount. And those are the points I wanted to tie into because they seem very solid, and they were used to support all of the weight of the stock engine and transmission in the back. Here's what it would look like with the engine, and this black section here is the existing frame of the vehicle. My schedule is seen up there. Various points I ran ahead or ran behind. The budget, the cost of the frame wouldn't have been too much. As you can see here, I was able to find recycled pieces, so I kept it very cheap. This I was able to find used. And then I assumed that it would take me about 25 hours to actually produce the frame itself, which would bring the total cost to an estimated $748 if I had to buy new parts and construct it at what I could get paid elsewhere. You can see the truck bed full of all the used stuff that I was able to recycle. Here I was manufacturing it, so what I did was I cut notches and then bent the arms so that I could eliminate a lot of the weakness of the weld joints. And then I had it all laid out, just cut out, but nothing welded yet down below. For the testing, I eliminated all the suspension components from the equation, so I put jack stands on the frame itself, on the front of the vehicle, and under the frame in the back. I then loaded up with 1,005 pounds of weight, and I also did a mock-up with the engine in it. So with the 1,005 pounds of weight, I loaded it up incrementally about 100 pounds at a time, and I didn't have a height gauge, so I just took my caliper and put it in the clamp, and made sure it was really solid on the ground. Here's the data that I got, and you can see the increasing weight, increases the deflection, and it made a nice linear line. I was able to, as I removed weight, I remeasured everything, and it was consistent. I forgot to record those, but I was able to confirm that the caliper had not rocked or moved or misplaced to skew the data very much. The results, with the 500-pound engine assumed at 2 Gs in the calculations, I got just about that 4 safety factor that I wanted. Off a 4-foot drop, I was able to get a safety factor of 1.59. The calculated deflection for the frame itself was supposed to be only 0.052 inches maximum. But when I actually measured the deflection in the vehicle, it was almost 0.2 inches. So that was one of the issues I had listed down here. The frame is successfully installed in just a matter of minutes using the bolt holes that I wanted. And I did it all on my own. It goes in and out quite nicely. The ground clearance met my requirements as well. It stayed really close to the frame of the vehicle, so it didn't protrude in any odd places. The issues for my jump, for the 4-foot drop, I was unable to verify the deceleration rate of the vehicle to find out the peak force that would be applied. I found one instance that online that could verify it, but I only ever found the one, so it is still an assumption that I have not been able to verify. The other assumption was that the vehicle would be rigid enough to successfully measure the deflection of the frame, and that was very not true. It was, as you saw in the numbers there, it was quite a bit more flexible than I had anticipated. So I've devised a way to retest it. I just haven't actually seen my bug even since I performed those tests. It's on the other side of the mountains. So the strength of the vehicle, I was not able to calculate that independently from the strength of the frame. So the two of them together, I could figure out, but independently, I have not figured them out. This is the video that's supposed to work. It just shows an overview of how the frame is mounted in the vehicle. You saw the nose where it was mounted, coming back. It bends there, and is mounted to the rear horns here. That is a heavy-duty engine and transmission bracket from an off-road bug shop. I was able to find it used for a good price, and it clears the transmission in a better way than the angle iron would. You can see that it does mount there, just like I was showing. Bends here, and I was able to eliminate most of the welding by having that bend rather than kind of two cut pieces. Here's a larger picture of the engine mock-up in there. And I'm still waiting on some other parts that were not actually part of the senior project before I can actually mount the engine and run it. I guess that's it. Any questions?